Okay, algebra students, this is the solutions video to the Skills Builder worksheet that we got today. There won't be any fanfare with this solutions video. We're just going to jump right in and solve the problems. Number one, if f of x equals x minus 9 times x plus 6, then what is the y-intercept? Use FOIL or the box method to support your conclusion. All right, so in order to understand the why behind what we're about to do, it's useful to remember the general formula for a quadratic. F of x equals ax squared plus bx plus c. Okay, whenever you do a quadratic and it's in standard form, the c value is the y-intercept. So this is the y-intercept when it's in standard form. Okay, it's hard to see that, y-int. So what we'd really like to find is this c value. Well, are we given enough information? What we are given is f of x equals x minus 9 times x plus 6. What we have to do is expand this into a quadratic equation. So we've got to multiply them together using FOIL or box. Okay, so if I'm going to use FOIL, first, outer, inner, last, here's what the solution would look like. First, I would multiply the first two terms, which is x times x, x squared. Then outer, so I would add the outer term, 6 times x, so plus 6x. Inner, it's going to be negative 9 times x, or minus 9x. And then last, the last two terms, negative 9 and positive 6, which is negative 54. Okay, so the thing we have to do here is combine like terms in the middle. So we have x squared, and then plus 6x minus 9x is minus 3x. And then on the end, minus 54. So now this is in standard form. Okay, ax squared plus bx plus c. And we can just circle the c term with its sign, negative 54. So the answer is negative 54. That's the y-intercept. Okay? But if you were going to prove this using box, just in case that was your style of proof, then here would be the proof. Create a 2x2 box like that. Up on top you write one of the factors, x minus 9, and on the side you write x plus 6, just like that. And now it's a game of fill in the box. X times x is x squared, 6 times x is 6x, negative 9 times x is negative 9x, and negative 9 times 6 is negative 54. And now we just write that all out. You write x squared minus 9x plus 6x minus 54. Again, combine like terms in the middle, and you've got x squared minus 3x minus 54. And once again, we can circle the c term. This is the c term. This is the y-intercept. Okay, so the y-int is negative 54. There's your actual answer, and you've shown how you got it. Good. That's all there is to number 1. Number 2, find and write an equation for a line passing through 3, 7 and perpendicular to f of x equals 7x plus 1. Show each step of your solution. Well, here's the first step. When I see the word perpendicular, I should probably highlight it or underline it or make a note of it. Perpendicular is triggering something in my brain. When I see perpendicular, I need to write down negative reciprocal slope. Negative reciprocal slope. Okay, and here's how that works. If you have a slope m, then the negative reciprocal of m is equal to negative 1 over m. This is the rule. Okay? So now we'll put it, that's the rule, we'll put it into practice. What slope were we given? Right here. We were given a slope of 7. So I'll plug in here, rule. If 7, then negative 7 to the negative 1, the negative reciprocal of 7 equals negative 1 over 7, negative 1/7. That is our slope of our perpendicular line. Remember what we're doing. We have some little graph here, okay, and it has a line that looks something like that. Okay, and what we're saying is that we want to find a perpendicular line that passes through 3, 7 and is perpendicular to this. So we're going to find some line that is perpendicular and passes through 3, 7. We want to find the equation of that line. We already know the slope is negative 1/7. So how do we find the equation? Okay, so that's 2. We are going to use the point slope formula. Use the point slope formula. So step 1 was negative reciprocal slope, and 2 is point slope formula. Well, what is the point slope formula? Here again we have this rule. Y minus y1 equals m, open parentheses, x minus x1, close parentheses. And so now it's up to me to fill in these two values, x1 and y1. And I'm given x1 and y1. Here's x1, 3, and here's y1, 7. See, they gave it to us in the problem, x1, y1. So all we're going to do is plug those values in here. So if that's the rule, then here's the specific case. Y minus 7 equals, now what's m? In our case, okay, because we have a specific example here, this m is negative 1/7. So I'll put in negative 1/7, open parentheses, x minus, plug in x1, which is 3. Okay, so now I've got to multiply through, distribute that negative 1/7. So I've got y minus 7 equals negative 1/7 x plus, negative times a negative, 3 over 7. And now to get y by itself, I'll add 7 to both sides. And I've got y equals negative 1/7 x plus 3 over 7. And now I'm about to write plus 7, but I need to stop and think. Notice the denominator here is 7. Okay, so I need this 7, which is right now really 7 over 1. I need this to have a denominator of 7. So the way you find that is you multiply 7 over 1 times 7 over 7. And that will give you a common denominator with the rest of these. And I can do that because 7 over 7 is just 1. So I'm multiplying by 1. That's allowed in math. So 7 times 7 is 49. 1 times 7 is 7. So I'm really adding 49 sevenths. And that's what I'm dealing with now. Y equals negative 1/7 x plus 3/7 plus 49 sevenths. So I'm okay here. I just need to add 3 and 49. So 49, 50, 51, 52. Okay, so here's the answer. Y equals negative 1/7 x plus 52 over 7. And there's no way to reduce that down because 52 and 7 don't have any common factors. So that's your answer to number 2. Okay, on to number 3. I might go a little bit over my time, but not much. We're at 11 minutes now. So if a function passes through x equals 4 and x equals 6 when y equals 0, in other words, the zeros of the quadratic function are 4 and 6, and it has a y-intercept of 8, write a quadratic function that satisfies these conditions and sketch its graph. Okay, this part right here is going to be the harder part, but we need to start working. So just to get a little bit of a picture of what I'm doing, I have this quadratic function, okay, and I know that its zeros are 4 and 6. And I've got to find out some things about it. So if I know the zeros are 4 and 6, what are the factors? So my first step is to turn the zeros into factors. Turn the zeros into factors. Well, how do I do that? Well, it's easy. So x equals 4 and x equals 6. In order to turn them into factors, you just subtract the 0 from both sides of the equation. Minus 4, minus 4. So those cancel, and I've got x minus 4 equals 0. This is the factor, x minus 4. Here I've got minus 6, so x minus 6 equals 0. X minus 6 is the factor. So my two factors of my quadratic are x minus 4 and x minus 6. So now how would I come up with a quadratic equation using this information? Well, here's what I've got. I've got f of x equals x minus 4 times x minus 6. So I need to use FOIL. So now number 2, here we're going to use FOIL or box to expand binomial. Okay, so I'll use FOIL. X times x is x squared. Okay, outer, FOIL. So outer, I've got x and I've got, negative 6. So that's negative 6x. inner, I've got negative 4 times x, which is negative 4x. And last, negative 4 times negative 6. Negative 4 times negative 6 is plus positive 24. Combine like terms, x squared minus, okay, two negatives, so minus 10x, negative 6 plus 4, negative 6 plus negative 4, minus 10x plus 24. Okay, now, here's the thing. This is the general, this is what we call like sort of correct. Sort of correct. Now, this is what bothers people. What do you mean it's sort of correct? Well, here's the problem. I don't know if you guys noticed this, but look up here. It says that the graph has a y-intercept of 8. Well, look down here. We have a y-intercept of 24. So what gives? Well, here's what's happening. Right now we have found a quadratic equation that has a y-intercept at 24. Okay, so it's going to look something like this. See if I have, I guess I'll have to use a pen. Something like this. Okay, that's what the quadratic we just found looks like. But that's not the quadratic they wanted us to find. They want us to find a quadratic that has a y-intercept at 8, lower, but that also passes through 4 and 6. So what would that look like? Well, it would be much more spread out. It would be like this. Oops. So in other words, shock, there are more than one quadratic equation that will pass through those two zeros. So you have to know what y-intercept you want. And there's the solution process to taking this information and applying it to what we found. So here's what you have to do. You have to multiply your entire quadratic equation by some factor a that we don't know. We have to find it. All right, but here's the quality that the factor has. We can set this equal to y. Now, everywhere I see a y, I'm going to put my y-intercept. And everywhere I see an x, I'm going to put the value of x when y is 8. All right, so y-intercept, whatever the y-intercept is, the value of x is 0. That's one of the characteristics of a y-intercept. So what I'm going to do is rewrite this. I'm going to replace the y with an 8 equals, and remember what I'm trying to find is this a value multiplied by, substitute in a 0 everywhere you see an x, minus 10 times 0 plus 24. Okay, so now what? Well, 0 squared is 0. Negative 10 times 0 is 0. So I'm left with 8 equals a times 24. All right? And if a equals a times 8 equals a times 24, then you divide both sides by 24. 24, 24. Okay, these cancel. And now you have then a equals 8 over 24. Now, 8 and 24 are both divisible by 8. So you're going to divide the top and the bottom by 8 to reduce the fraction. And you get 1/3. So A is 1/3. That was really important for us to find. A is 1/3. Now we have to plug that back in. So 3, plug A back in. So now I'm going to rewrite this. Y equals, instead of A, I'll write 1/3. 1/3, open parentheses, x squared minus 10x plus 24. Okay, and so what I've got to do now is just distribute the 1/3 through the equation. So y equals 1/3 x squared minus 10/3 x plus 24/3. Well, 24/3 can be reduced. 24 divided by 3 is 8, and 3 divided by 3 is 1. So this whole thing just becomes 8. So I'll rewrite my final is y equals 1/3 x squared minus 10/3 x plus 8. Okay, so that is the equation of the specific quadratic. And here's how I know I'm right. Because it has the y-intercept of 8. It has a y-intercept of 8. Okay, because the video has gone on beyond what I said, we will skip that part of sketching the graph, and we will just, this right here will be good enough, because it's 22 minutes long at this point, and that's long enough for 3 problems. We'll leave it just like that. Y'all make sure that your paper looks like this, and you know, this shows the work that goes into doing real algebra. Okay? So I hope this was helpful to you, especially on number 3. Next time, we might have more time to actually take this information and come up with a good sketch, but we'll leave it right there for now. Thanks.